Hi everyone, so today I'm going to discuss about 10.2 concavity points of inflection. So especially here we are going to learn about the applications of second derivative and how we can find the concavity of a given region or for some point, and how we can find inflection point, and finally I'm going to discuss about drawing, how we can draw some graphs by using the first derivatives and second derivatives. Okay, now let's start our lesson today. First, I am going to discuss about concavity. So now I think if I use some diagram, it will be helpful to understand the idea. So this is the diagram. So look at the definition: concavity. A curve is said to be concave up on an interval AB. So this is the interval AB. This is our curve. So we call this curve is concave up in this interval AB if at each point on the interval, it means any point of the interval, the curve is above the tangent at the point. It means if we draw any tangent at some point, always curve is above. So you can see in here, here, and any place. If I draw tangent in here, it is also curve is above. For such a case we call concave up. So this is the concave down. So in here you can see in this interval CD, if we draw any tangent at this interval CD to any point, you can see curve is always below the tangent. In here also you can see this phenomena in any point you can see it. So for such a situation we call concave down. In generally when we are going to learn about concavity using second derivative, we can discuss about concave up and concave down. So let's look at this definition. This is very important. So concave up and concave down, how we can find it mathematically. So the function f is concave up on an interval I if second derivative is positive, and concave up at some point. So first we call about concavity of an interval and then concavity of a point. At that point, I mean, if I substitute that coordinates to second derivative, then if it is positive, then it is concave up. For similarly, the function f is concave down on an interval if the second derivative is negative on that interval, and concave down at a point if we plug this point to that second derivative. If they are negative, it is concave down. So look at this example. First, if the graph is given from this function, concave up or concave down at the point. So first what we need to do, we need to find the first derivative and then second derivative, then plug in the point into this second derivative, so you can obtain it is -2. So second derivative is negative, means it is concave down at this point 1, 0. Let's move to our second point, 2, -5. First find the second derivative and plug in the point 2, then you can obtain it is 4. So it is greater than 0. So it means it is concave up. So very easily using the second derivative, you can find the concavity at some point or some interval. So now I am going to discuss about point of inflection. We call that this is a maximum and this is a minimum, and especially for such a case we call as inflection point. Sometimes it may be like this way. It means it is always increasing or always decreasing. So basically we can find point of inflection very fastly actually if the concavity change at some point f naught. For that point we called as an inflection point. In other words, if the second derivative at some point is 0 or undefined, we call it as inflection point. So this is very important. So if the second derivative is 0 at some point, it is a point of inflection. Remember this one, this is important. And we can check also if the concavity change at some point, then also it is a point of inflection. So now look at this example. So first you are given the function, then we have to find second derivative. So by equal this to 0, we can obtain at which point the second derivative becomes 0. So second derivative is 0 means these are inflection points. So now using this diagram you can find the behavior of concavity. So in the interval of negative infinity to 0, choose some point and plug. As an example, I can plug some value as negative 1 or something. If I plug for this one, it is positive, so it is concave up. Then choose some value between 0 and 1, take half, then plug to this second derivative, then you can see it is negative, so it is concave down. Then after 0, 1, choose some point as 1, 2, 3, 5 or some value which is greater than 1, then it is positive, so it is concave up. So in this point and this point, I mean 0 and 1 are our inflection points. Then using these inflection points we can draw the diagram. So this is the diagram according to given this information. 0 and 1 are our inflection points. So up to 0 it is concave up, it is given, and after in between 0 and 1 it is concave down, and again after 1 it is concave up. So this is the method how we can draw some graphs using the second derivative, but then try to do this example by yourself. I think it will be easy for you if you follow our previous example. It is not so much hard. Then let's look at the second derivative test. So using the sign diagram we already have find the maximum and minimum, you know it, I mean the sign of the derivative, positive or negative. Then we draw some sign diagrams. As an example, if it is positive it is increasing, and if it is negative it is decreasing, so it is a maximum. We decide like this way. Now using second derivative test, very fastly we can find whether it is a maximum or minimum. So method is this one. This is important point. If second derivative is less than 0 at that point, it is a relative maximum, and if the second derivative is greater than 0, it is a relative minimum. So you need to memorize these things. These are very important. And now let's look at our example. Find the relative maximum and minimum of this given graph. So to find the maximum and minimum, it means critical points. So to find critical points, find the first derivative and set it equal to 0. So you can obtain -1 and 3 as your critical points. Then find the coordinates of them. It is -1 and this one, and 3 comma -7. Then we know that our critical points are this one and this one, but we don't know whether it is a maximum or minimum. Now I am going to use this second derivative test. So find the second derivative and plug this point into the second derivative. Then this is the second derivative. Then you can obtain, first we are going to plug our we have two, yes, 1 and -1 and 3. First we are going to find 3. What will be the 3? It is maximum or minimum. So first I substitute 3 for the second derivative, so you can see it is positive. So 3 comma -7 is the relative minimum. And similarly, by plugging -1 for the second derivative, you can find it is the relative maximum. So this is the relative maximum and this is the relative minimum. In our previous day we have learned this same thing by using sign diagram, but today we learn this one using a second derivative test. I think second derivative test is very fast, but the problem is in sometimes if the function hasn't a second derivative, then we can do it. Okay, thank you everyone.